All right, kids, we're going to talk about substitution today. This opening problem is just a review practice problem by graphing. So you should stop this and just do this yourself. I'm going to quickly do it in a moment, but this has nothing to do with today's lesson. Okay, this first equation, remember, solved by graphing, you would want to be equal to y. Sorry, you want to have y equals. So we would subtract x from both sides. We would get negative x minus 2. So there's the y-intercept. Slope is -1, so it's down 1 over 1. And we should do this a bunch of times because we never know where the other line is going to be. I'm going to go backwards, up 1, left 1, a number of times. And there we're all set with the first line. So I'll do the second one in red. Same thing though, we have to solve for y first. Don't forget to bring down that -3y. Now we have to divide everything by -3. These negatives cancel. These negatives cancel. So we have a y-intercept of +3, and we have to go up 2 over 3. But that's taking me farther away from the line, so let's go backwards, down to left 3. And you see our magical points right there. What's that? -3, 1. Remember, if you wanted to check that, you can verify it in both of these equations. This -3, 1, if you plug it in for both of these, it should work in both equations. Okay, so we're going to talk about substitution. So substitution is a third method of solving systems. We started with graphing, and pretty much everyone starts with graphing because you create that visual of the two lines and where they intersect is the solution point. But it's cumbersome. And then I showed you elimination, which is a much better method than to solve by graphing. But then there's a third method called substitution. Now, substitution you should really only use if one of your coefficients in the problem is 1 or -1. So for example, the coefficients are the numbers that are in front of the variables. Like this is a coefficient of -1, that one's 1, this is 2, that's 1. These numbers out here on the right, they're called constants because there's no variable with them. They don't change. That's something different. If you have as long as you have one variable with a coefficient of 1 or -1, substitution is a decent option. Okay, if you had something like this, 4x plus 5y equals 17, 9x, I'm just making this up, minus 7y equals 12. You see, these coefficients are 4, 5, 9, and -7. You have no business using substitution here ever. This should be an elimination problem, that technique that you already know. Okay, so here, my eraser's not working. That's weird. There we go. In this in this problem here, though, we do have coefficient of 1. We have it in both places, actually. So your first step is to solve one of the equations for a variable, but only solve for a variable that's got a coefficient of 1 or -1. I'm going to solve this top one for y. Okay. So all you have to do is move the x over, and that goes away. I'm going to write it over here. I get y equals x plus 1. Okay, now what that means is y is the same thing as x plus 1. So we can take that x plus 1 and substitute it into the other equation where y was originally written. Okay, so I'm going to now rewrite the second equation. 2x, but instead of writing plus y, I'm going to write plus x plus 1, and it still equals -2. But now we just have one variable, and this is easily solvable. 2x plus x, of course, is 3x. We're going to move the 1 over, so we get 3x equals -3. If I divide by 3, I get x equals -1. So like an elimination, we're not done yet. We have to go and plug into one of these equations, one of these original equations. So look, I'm going to take this -1, I'm going to put it in here. The negative of -1 would be +1. Move the 1 over, and we get y equals 0. So our answer is -1, comma 0. There you go. Okay? So just like an elimination, after you solve for the first variable, you still have to go and solve for the second variable. Excuse me. Now on the back side, this next problem, maybe you want to try to do it yourself first. This next one's actually easier because the first equation is already solved for a variable. The first equation is solved for y, right? Y is the same thing as x plus 4. So we're going to take that and substitute it into the other equation and rewrite that equation. But instead of writing 3x plus y, we're going to write 3x plus x plus 4 equals 16. I'm going to combine like terms and move 3x plus x is 4x and move the 4 over at the same time. And you get, excuse me, x equals 3. Now, we can just do this, the plugging in our head. This is so easy in this problem. If I plug in the 3 here, 3 plus 4 is 7. So you get an answer of 3 comma 7. See, that one was easier because, you know, the first equation was already solved for a variable. All right? Now, in this next one, you know, you could do this problem with elimination. I want you to realize that. You know, elimination, the technique that we did before, would work just fine. It would work great. But, you know, let's practice with some substitution. The only reason that we can do substitution here is we do have a coefficient of 1 here with the x. See, we don't want to solve this top one for x because it's got a 2. We don't want to solve it for y because it's got a 2. We don't want to solve, but we can solve this one. Remember, we don't have to solve for y. We just have to solve for a variable that has a coefficient of 1 or -1. So I'm going to solve the second equation for x by moving the 4y over. So x is the same thing as 4y minus 1. So now we got to go and plug in for x in the other equation. Okay? And now that 2 is still there. But now instead of 2 times x, notice how I have to introduce parentheses because I have to multiply by this binomial 4y minus 1. Don't forget about this plus 2y. It's still there. Now, of course, you guys all know we're going to distribute 8y minus 2 plus 2y equals 3. Combine like terms and move the 2 over at the same time. So we get 10y equals 5. We're actually going to get a fraction here. That's okay. It's not an ugly fraction. It's y equals 1/2. Okay. I'm going to go into the first equation. So 2x plus 2, but remember, y is now 1/2. Well, 2 times 1/2 is just 1. Move the 1 over, you get 2x equals 2. X equals 1. So our answer is 1 comma 1/2. There you go.